All right, good afternoon. Let's get started. All right, quick reminders. We have our second homework that is just due. Okay, so make sure you have submitted your homework. We don't have another one coming out this week because we are going to have our proposal meetings next week. Okay, so make sure you have submitted homework too. And then if you go into Canvas, you will see we have a few items for you to do. Excuse me. One, we have posted this meeting availability survey, so it's due today. Okay, this is just to check your group's availability, so we can schedule next week's meetings. Okay, because our plan is to meet with each group, so we'll listen to your project ideas, we'll provide feedback. So we are talking about a large class and many groups, so that is going to be challenging. So that's why we want to get your availability. And in the survey, we specifically ask you, please be flexible. So select the ones that could work for you, right? The ones you prefer, the ones that could work for you. And if any other constraints or other times that may work for you, please let us know, because that would really help us in terms of scheduling, okay? So please, as you form your group and figure out your project, right? We're not asking for specific project information yet, right? So just let us know how many people, because that is basically we're allocating slots based on the group size, okay? And also, if you have a title, great, put it in. If you don't have one yet, fine, put in a tentative one or just say TBD, that's all fine, okay? Right now, we have a way to assign slots to your group, okay? And some of you are ask, if our group is still forming, we're not finalized, it's okay. Put in what you have by tonight, okay? So we can at least plan for that, okay? The group can change. You can add people if you need to later, okay? So changes are totally fine afterwards. So don't feel that you have to commit to everything at this point, okay? We just need information so we can schedule the meetings, okay? So next week, we're going to spend actually our time possible, right, for the project meetings. So we are not going to hold regular lectures or office hours, okay? So you don't need to come in here just for lecture, but we are going to have the project meetings, okay? No regular office hours. Sorry, we just don't have a lot of bandwidth next week. But if you do need to meet with us, please reach out either this week or for next week or later if you can. But we can find time maybe to talk to you if needed. Okay. So we have posted in Canvas, right, what you need to submit, okay? So we'll talk a little bit more about what we're expecting for the project proposal, okay? So at a high level, we say, okay, we want you to form groups, right, work on a project that can apply data mining techniques to real-world problems, okay? So it's really a lot of flexibility. I know that's making it challenging, but hopefully that also allow you to work on something that's interesting for your team members, okay? Group size, as I have said, right, we recommend 3 to 4, okay? That seems to be a good size, you can work on a reasonably large problem, but still be manageable. I've already talked to a few groups, right, either smaller or bigger. That's fine, it's allowed. I just want you to check with me, okay? Because what we're looking for is that we want you to have successful, right, project outcome, okay? So with the larger groups, it is harder to manage, okay? So just make sure if you want to have a larger group, the group members are all clear that there is effective communication, so it is still manageable, okay? Smaller is fine if your particular project situation calls for it, but again, check with me, okay? But at a high level, right, what we're really looking for is that for your group size, for your group composition, we're talking about undergraduate versus graduate, okay? You can have a mixed group of members, but just knowing that we want the project scope to be appropriate for the group, okay? Meaning that you have, say, a larger group, right, which probably the group will be able to do a bit more. If you have more graduate students on the team, we're also expecting a bit more contribution from the graduate students, okay? All right, some high-level things. So we're in week 4 next week, week 5. So we're going to do the proposal meetings, okay? After that, we'll be it's 6 weeks in between when we come back for the checkpoint, okay? Just to make sure that things are on track and provide feedback if you need some updates or changes, okay? And week 16, that's the last week of class. That's when we finish, okay? We don't have final exam, okay? All right. Okay, so what goes into your proposal? Okay, so project proposal. Okay, so there's a format or template you can follow, and you have actually seen this for the KDD papers, right? For homework 1, I think it's actual credit for undergrad. But if you haven't done it, right, you can go into, say, like the KDD website, take a look at the researcher papers. Okay, of course, you don't need to check all the details, but generally, it's how we kind of provide a story, right? You want to tell a story about your work. Okay, so these are the core sections we're looking for. Okay, so kind of give you a bit of kind of outline. You want to start with a good introduction, right? Introduction, you say, what is a problem? Right? What is the problem you're trying to solve? Why this problem is important? Okay? So you want to have some reasoning, okay, about why you pick this problem. Okay? Then related work. So we want you to be aware of what has been done. Okay? So generally, I would say like data mining is a very, active field, broadly applicable. So you can probably find something that may have been done already or related to what you're trying to do, right? So we don't want you to be just repeat what has been done, okay? So we don't want a project that, I want to just kind of follow whatever the other team has done and just like repeat the process, like redo, kind of say what I get the same result, okay? I want you to think about what goes beyond what is already done, okay? So that's why I say encourage you to check, right? Existing work, existing data sets, existing tools, build upon that, okay? You don't need to be re-implementing everything, okay? Take what has been done, but then really think about, okay, what you can do, right? Given what has already been done, okay? Proposal work, this is basically what you plan to do, right? So you have like one section there, but underneath that, you decide what you want to write in there. What we're basically looking for is that, what do you have, right? Kind of like you plan to focus on, okay? Again, this is not a binding. It's not a commitment. Things can change. You don't need to spell out everything. Just put in whatever you have figured out so far and what you're planning to do. Okay, so we're looking for there, right? Proposal, of course, is say, okay, given this problem, given what has been done, so your proposal would talk about what kind of data you're going to use, what kind of tools you're going to use, what kind of platforms you may use, right? And then get into some a little bit specifics about, okay, if you have some particular questions you like to explore, okay? No answers yet, right? But just say like, okay, these are the things we'd like to explore. And if you have some actual idea about, these are potential techniques we may explore. If you don't, fine, okay? And then really think about your evaluation section, okay? Because you want to think about whatever your problem you're trying to attack, techniques, whatever. Even if you don't have the solution yet, right? You should think about how you want to evaluate, okay? How do you claim, right? This is something interesting, how you say this model is good and this actually is what I need. So consider your real world need, right? We have been talking about efficiency, right? Effectiveness, right? Does your problem require certain latency? Or does your problem require certain scale, okay? Or it has to I want to see whether my model has a better accuracy or something like that, okay? So put in whatever you have, okay? Because what we're really looking for, for your proposal, is a good reasoning. Reason about the problem, reason about what you know already, reason about what you like to do and why you want to do it this way, and how you want to evaluate, okay? So with all that, and the last one is shorter, but just say have a way of kind of talking about the milestones. This is something particularly if you're in a group, right? Make sure you check with your group members. By now, you should probably all know for the coursework you have, right? When you're going to have midterms, when you're going to have final exams, whether you have projects some here and there. So just kind of look at your own schedule, but then communicate, right, within the team, right? Say, okay, this is probably the time, we can probably do more here. Or they say, this week I'm traveling, or I have a midterm or a major project deal, so I cannot do much. But just kind of communicate that ahead of time, okay? So that you have a bit of kind of idea in terms of when you would like to finish what, okay? Now, we had some discussion, right, about how to get started. So by now, hopefully you all have some ideas, but I want to just kind of highlight a few things, right? Really, I want you to work on something that interests you, right? Some teams that still say, oh yeah, we're exploring a few problems, right? We're trying to decide. Ultimately, it's about your interest. And the second is about data, right? What interests you, what data is available for you to do that. And of course, team, right? It's a team project, right? So make sure you communicate about the team. And when you're on the same team, that doesn't mean that you need to be all working on the same tasks, right? The specific tasks can be different. Could be just different angles, right, of the same problem, but you may be exploring different data sets, or you may be kind of like looking at the different like techniques, right? So those are all possible, right? So as you're talking about, right, the different views right here, I know a lot of you have been asking, like, do you have some list of projects, right? I don't want to give you a list because there's just too many, right? But here, just a way as like you think about your project, right? We talk about the 4 different views, okay? Application, right? What is the application scenario? Because that usually is actually good motivation for your problem, okay? And then when you get to the application, think about the data, okay? There are all kinds of data, right? See what kind of data you can pull in, okay? And knowing that usually it's actually interesting and useful to work with different types of data, okay? And then, of course, the knowledge, right? With the data, with the kind of application scenarios, what kind of knowledge you're trying to learn, okay? And then method, right? We will be talking about more. We just started talking about like the frequent pattern mining, right? That's the beginning of some of the methods. But I really want you to think about whole pipeline. Because when people say, okay, think about methods, oh, are we going to talk about like classification, clustering, those some of the deep learning models? Yes, you can use that, right? But if you think about the whole pipeline, right, these are all important, right? If you have your data set, right, remember what we did in terms of understand your data, right? Do some statistical analysis, so do some kind of plotting to show whether your data is skewed or have certain patterns, right? And then the pre-processing, if you're working with any real-world data, right? I'd like to hear your report later. It's like how much of the pre-processing you need to do, okay? Like make sure you have a good, right? Analysis there and some like justification, right? Either say, yeah, it's clean, it's very good, we checked, we can just use it. Versus, oh, actually we had to do all this to prepare our data, okay? Data management, that's actually also a very important aspect, right? As I said, like if your problem is smaller and within your team, you say, okay, we just have one repository, maybe fine. But if it makes sense to use some kind of database or some other like tools to manage your data, think about it, right? How that can make your process more efficient, okay? And then you get to the modeling, right? Various kinds of models, right? Depending on whether you're looking at frequent patterns. Later on, we'll be talking about classification, clustering, anomalies, and a lot of the kind of newer models, right? A lot actually from the like deep learning frontier. So all those are things you can leverage, okay? And then think about how you're going to evaluate, right? So those are all the things that you can try to kind of like think about, right? Do your reasoning. Okay, that's really the key, right? We want your projects throughout the process to show analytical thinking, right? You're doing the reasoning rather than say, oh, this is what I'm going to do, right? Whatever you want to do, whatever you have decided to do, right? Provide some kind of justification, okay? And that is really the most important skill, right? Because if you go out to the world for your job, for anything like in the future, the problem will be very different. The data set will be different. Right? It's really about your analytical capabilities and the knowledge you have learned, right? Putting them together so you can explore new problems, right? Come up with new solutions and new results. Okay. All right, key points, right? So start early. That's what I say, not just for proposal. Because I know next week we'll be doing the proposal, and I don't want you to say, okay, I'm done with the proposal, come back in 6 weeks. So like, yeah, that'll be week 11. Then you say, okay, let me pick up what I did from the proposal. Continue doing it. So this early is about basically throughout the semester, right? Do more you can, okay? I don't know about your schedule, right? Usually towards the end of the semester, no matter how you plan for it, it will be busy, okay? There'll be more things piling up. So things usually tend to be more like busier towards the end of the semester. So try to do more upfront, okay? Data availability, check out that soon. By the time you do the proposal, better make sure that you have the data or you know you're confident you can get the data you need, okay? The next one is something I think is very helpful and actually very good for your group management, okay? It's about prioritize the subtasks, okay? At the set, usually it's difficult, right, to know upfront, okay, what kind of results you get, how a way a particular model would work, right? So try to brainstorm, right? More of those different ideas, different subtasks, and then you can assign those subtasks among the group members, right? So that you have a way saying, okay, yeah, those are things we'd like to explore. It's prioritized. So you start with something, You can shuffle things around, add things, remove things along the way, but you always have maintain this, right? Prioritize the list. Okay. Existing tools already mentioned, team coordination, I already mentioned a few times, right? I said really it's important because every year I see challenges, right, from some groups. Especially not because the work itself is hard, it's just group of members, right? If you have one member of your team who's not communicating well, that will probably be hard for the whole team, okay? So just really make that clear upfront. It's always easier to set up some schedule upfront, and then people just maintain that, okay? And as we said, we will be assigning grade based on individual contribution, right? So when you're in a team, we look at, of course, the overall project, but we will be looking at individual contributions, okay? So just make sure you as a team member is contributing, okay? All right, so some of the specific things, project meetings next week, okay? Please finish the survey today. So then we can, we'll take all the input you have, and tomorrow we're going to post the schedule, okay? When it's posted, please check, make sure it works for your team. If there's any kind of thing that you need to change, contact us right away so we can make adjustment as we can. But we are really limited because, as I said, we have many groups, so we need a lot of time to do the scheduling. So please put in the survey on time and then check the schedule when it's posted tomorrow, okay? So what we're going to do for next week is that me and the 2 TAs, right? So we'll be present, okay? So you're basically presenting your project ideas to us, okay? So we're basically just providing, we'll be asking some questions, clarifying questions, so we'll provide some feedbacks that's really just to help you, right, to formulate your project better, okay? Those meetings are open to the whole class, okay? So when we meet in person, everybody, you're welcome to come to the classroom here during the class time. And then for outside the classroom class time, we are going to have Zoom meetings, okay? That's also open, okay? Because we want you to be aware of, right, what your classmates are working on, okay? The presentation itself, so we'll allocate, of course, based on group size, but typically we're looking for really not a long time, right? 5 to 10 minutes to really kind of hit the core ideas of your project, okay? You don't need to give us all the details because we are going to read your proposal report, right? That can contain more of the details. So your slides doesn't need to provide all the information, but give us a good high-level overview of what you would like to do so we can provide useful feedbacks, okay? Now, specifics, right? So survey, hopefully all of you are planning to finish it today, okay? Next week, there are 3 things, okay, that will be due on Friday. Okay, why Friday? Because we'll be running meetings from Monday all the way till Friday afternoon, okay? So the plan is that after, you can prepare your project, the presentations and the report, but after talking with us, right, you can update it as needed and then submit, okay, by 10 p.m. Friday, okay? So by that time, there's 3 things. One is this project announcement. If you go into Canvas, right, it's just it's just discussion thread, okay? So once you post it, then you can see other people's posts. Okay, so the general idea is that like I said, I want the whole class to know what's happening, right? What kind of projects people are working on, okay? And sometimes, actually, you'll find, right, there are other groups working on related problems, okay? So you can definitely connect if needed, and sometimes you can share data resources as needed, and we can just help each other, okay? And then for the announcement itself, we're not looking for a lot of information, right? Just to say, title. Hopefully by then you have a good title, okay? As I said, I'm looking for informative titles, right? So that you put in some keywords so I can remember just by reading a title, I know which team it is, right? Team members, so here we basically say who's on the team, put in undergrad, graduate section. Brief description. Let's say brief really just a couple of sentences, right? Just say, what is the problem? What are you trying to do, okay? If you have particular data sets you're interested in using, particular tools, you can mention that. But that said, right, we're not looking for a lot of details in this announcement, right? It is intended to be brief, but it just be, so that the class knows what your group is working on. Okay, so that's the announcement, one item, okay, not too much. Next one is your proposal slides, right? This is what you're going to use during your meeting with us, okay? As I said, you can update it afterwards, right? Just make sure you submit. By the time you submit, you have it ready, okay? So the idea is that the slides is what you use to kind of drive the presentation, right? So, excuse me. For the slides, what we're looking for, right? Of course, have the core key information, title, team member, okay? And then just as we said, right, what goes into your proposal, introduction, related work, proposed work. If you have a data, you have subtasks, you can mention that, evaluation milestone, okay? So as I said, we're not talking about a lot of time, right? 5 to 10 minutes tops, okay? So your slides don't need to have a lot of information, okay? But just make sure you have those like core pieces, like roughly I would say 1 slide per item, right? 1 slide with the title team, another slide introduction, another slide related work, another slide proposed work. If you want to use another slide, you're probably fine, but that's about it. We're not looking for a lot of details, okay? Evaluation milestones, okay? One more item, okay, proposal report, right? So this is the one that you're going to like put in a bit more details, right? The presentation and the meeting, we cannot go into all the details, but the report you can put in more information, okay? And also this is what you're going to take like to expand, update for your checkpoint and for your final meeting. So you're not wasting your effort, right? So this is whatever you have so that you can build up, right, for your final report. Okay, for this one, we have put it in, so if you go into your Canvas, right, we're providing links. So this is a template we want you to use, okay? So there are a few options if you use like Microsoft Word, LaTeX, or Overleaf. So those are just different ways. It's actually, the template should be reasonably easy to use. If you haven't used it before, just check it out, right? If you have questions, of course, like post in Piazza or ask during the office hours, but hopefully it's reasonably straightforward, okay? The main idea, just make sure you include those information. As I said, right, those sections may be expanded, updated later as you build up your project. We don't have a hard limit in terms of how many pages your proposal report need to be. A kind of general guideline is about 3 pages. But don't worry about that as a limit, okay? I just make sure like putting, as you're writing those information, right? So you have those relevant information for your proposal. Okay, any questions? Good. Hopefully it's generally clear. As I said, if you have questions, post it to Piazza, that's good, okay? But as I said, next week we don't have office hours, so if you have questions, Piazza is probably the best way to reach us quickly, okay? And then, of course, let's say like during the project meetings, if you have specific questions related to the project, you can ask during that time. Okay? Good. All right, so with that, okay, we're going to continue our discussion, okay, of our lecture. So we started talking about chapter 4, right? So this is the second part of our course, right? We finished a bit of more like the intro prep kind of chapters. Starting with chapter 4, we're starting the core techniques, okay? So the very beginning is about frequent patterns, right? Patterns that occur frequently in your data set, okay? So some of the basic ideas we covered, right? What do you mean by frequent pattern? Right, so that depends, of course, what kind of data you're looking for, what kind of pattern you're looking for, okay? So if you have item sets, right, things that occur or occur together, right, those are the frequent item sets, okay? But if you have like sequential information, so those could be frequent subsequences. If it's a graph, it's like substructures, right? So generally, you're just looking for things that are frequent. And then to define frequent, what is the term metric we talk about? How do you measure whether it's frequent or not? Support, right? So support value is really like the percentage or the probability of something happening in your data set, okay? But then we also talk about confidence. What is confidence? Support is the probability that something happen. What is confidence? Conditional probability, right? If one thing has happened, what is the probability of something else happening? Okay? And that we're trying to use, right? So as association rule. So association rule looks at frequent, right, like frequent occurrences, so that's the support part, and also the confidence value, the conditional probability, okay? So we had this question about like giving A, what's the probability of a D happening, versus giving D, the probability of A happening, okay? So it's important, those two, since they're conditional probability, they're not the same. The support is the same. Confidence is different, okay? And then we started talking about the methods, right? So we say that, okay, you want to find frequent item sets, okay? We talk about how the brute force approach would not be feasible because this is exponential, right, possibilities, okay? So we say that we want to find a method that can be better. Okay, so we started talking about the a priori algorithm, okay? So the key property for the a priori pooling is that if something is not frequent, then any superset of that cannot be frequent. So you don't need to worry about it, right? So then with the a priori algorithm, right, what we did, right, the steps are simple. You do multiple scans. You do the first scan, you get the frequent one item set, generate the candidates, and then calculate the support value so you can filter out the candidates that are not frequent. And once you finish that round, then you can use the frequent K item sets to find the frequent K plus 1 item sets, okay? So the key steps are the scans and then the candidates and then counting the support, right? And then we then said, okay, that actually is slow if you have large number of items, transactions, and candidates. So we started talking about ways to improve it, right? First, to reduce the data scans, what did we talk about? Anybody remember what methods we're talking about if you want to reduce your data scans? Sorry? Sorry. Dimensionality reduction? Did we talk about that? So if your data set's too big, sampling is one method, right? So sampling, basically, let's say you want to reduce your data scan, you want to make your data set smaller, right? How do you make it smaller? Sampling is a good way to do it, right? So you sample a subset, okay? And then you run the frequent item set, the a priori algorithm, right? It is more efficient. But we then said, okay, one sample is not sufficient, right? It may actually miss out things. So you probably need multiple samples, okay? But even that is not guaranteed to find everything. What's the other method that would guarantee to find the, somebody? Hashing? Hashing, yeah, hashing is a way to, but that's actually the next item. Yeah, we'll come to that. But there's another one, besides sampling. I'm sorry? PCA? We didn't talk about PCA there. Another one's partition, right? So partition also makes the data set smaller, but it's guaranteed to find all the items because you're not losing information. You're still checking, right, all the data. Unlike sampling. Sampling that may be skewed, right, by the particular sample you're running. So you can increase the probability by multiple samples, but that doesn't guarantee finding everything. So we talk about partitioning, sampling. We also talk about the reducing transactions, right? That's also a way to reduce the data scan because now instead of looking at all the transactions, you only look at the transaction that may contain your candidates, right? Okay, and then hashing, that was what actually we talk about for the next one, is about reducing the number of candidates. Because with the hashing, right, you can actually assign or you can hash multiple candidates to the same bucket, right? So then you are basically counting the buckets instead of the individual candidates, okay? So if multiple candidates, right, their combined support is still below your threshold, right, then you don't need to consider them. Okay, so that way, instead of like counting the individual candidates, you only look at the buckets, which is smaller, right, than the candidates you have. Okay, I think we'll stop there. The last one is about support, right, counting support, right? So you got the candidates generated, okay? Now you need to count the support. How do you do it? Right, with a priori algorithm, right, the general thing is that, okay, for, let's say, giving my candidates, right now I'm saying I'm doing the K plus 1, okay? Now I have that my candidates generated, okay? What do I need to do? I go through the database, another scan, right? I scan through the database. So that means I'm scanning through the transaction table. For every transaction, I now need to check whether this transaction contains this candidate or not, right? Okay? So that's how you do it, okay? So you basically need to go through each candidate, actually go through your database. For each transaction, you need to go through each candidate and then check, right, whether the candidate is in your transaction or not, okay? So you can do some calculation of the computation complexity. You'll see it's actually pretty big, okay? So we actually have come up with another way. This one is called a hash tree. Okay, so the idea is that instead of a list of candidates, I want to build this data structure, okay, it's called a hash tree of candidates, so that I can find the candidates and count the support more efficiently, okay? So some of the key ideas, right? So for the hash tree, right, you have a leaf node, you have an interior node, and you need some kind of a hash function, right? How you follow each branch. Okay, so let's look at an example already. Okay, so here I'm looking at 3 item sets, okay? So first, the leaf nodes are the candidates. Okay, so for example, I somehow generated, right, 145, 124, 457, so those are all the potential candidates. So I need to count the support of those candidates. Clear so far? Good? Right, leaf node, okay? And then I need to go through the transactions, right? So as I scan through the transactions, I take a transaction. For example, I have 1, 2, 3, 5, 6. Okay? I need to check, right? Which candidates are contained in this transaction? Okay? If you're just eyeballing this tree and this information, like which ones? Which candidates are in this transaction? Can you see any? Anybody see anything? 1, 2, 5, that's one example here, right? Okay, so if you don't have this tree, what you need to do is that you have a list of candidates and you have this transaction, okay? You generate, right? From this transaction, you can generate the 3 item sets, right? And then just compare, right, with this list, okay? But here, we're using a hash tree, okay? Our subset or hash function is very simple. Okay, what I do is that I have every branching point, I check, okay, which item it is. If it's 147, goes to the left, 258 goes to the middle, 369 goes to the right. It's just a way of shuffling, right? Assigning sense based on the items, okay? So if you follow this tree, for example, like if I'm going to check 125. So first numbers 1, I go to, which branch do I follow? Left, right? That's my function here. So 1 goes to the left, so that's why I come here, okay? And then I have 2, middle, right? Then I have 5, also it's middle, right? So that is how I find a candidate using my transaction. Is this part clear? How you follow a tree? So let's try something different, okay? I could have 3, 5, 6. 3, 5, 6, so how do I follow this? 3 goes to right. 5, middle, right? And then here, as you can see, right, I don't need to go down further because I already stopped at the leaf node and I can check, oh, 3, 5, 6 is here. Okay? So that's how I check. And similarly, for you to construct, same thing, right? Before you assign those candidates to the tree, you basically take each of those candidates, you know that, like, same procedure, right? So for example, like 159 here. If it's 159 as its candidate, right, I need to decide where to put it, right? So 159, so that's a position, okay? So to make this process work, right, you take the candidates, you build this hash tree, okay? And then you can go through the transactions, okay? This just makes, so instead of, like, for example, like if you have, say, 1,000 candidates, if it's a list, it's big over n, right? It's a linear comparison. So you need to go through all the n candidates to check whether you have that candidate or not. Using this hash tree, what is the complexity? Do I need to check 1,000 times? No, because I'm branching, right? So it's a log base 3 of n, right? So it's a log complexity. So that actually is much faster because basically you're looking at the height of this tree. And that is that's the steps you need to use in order to check whether you have that candidate or not. Make sense? Okay, so for a small number of candidates, maybe this doesn't matter. But when you have many of them, this will be big save. Okay, so now I'm making my process of calculating candidates much more efficient. Okay, any questions on this one? So this is just it's a simple idea, but it's really, really useful in this particular scenario. You're basically just applying a data structure, right, to speed up the process, right, converting the linear comparison to a log n complexity. Okay? All right, one more approach. This one called vertical data format. Remember, so with our transaction table, right, we're basically recording things like this. So in this transaction, I have those items, okay? So if you remember our earlier discussion of the, which one? The inverted list, right? So we're saying that instead of recording this, we're using the vertical data format. So based on just saying these two items occurred in those transactions, okay? Remember we're talking about the search engines, right? They have so many documents. The documents have keywords, right? So instead of checking all the documents to see whether they have a keyword or not, you build up this inverted index so that you know which keyword occurred in which documents, right? So now for you to figure out, right? So for example, if you have a way of saying, okay, item X, right, or item set X occurred in transaction 1, 2, 3, and then you know item set Y occurred in transaction 1, 3, 4, it's a very simple operation for you to figure out which transactions contain X and Y, the union of the two item sets. Okay, so just with that vertical data format, we're making this process much more efficient in terms of finding transactions that contain particular item sets. Okay? All right, so all those are just methods, right, to speed up the process, okay? But these are all ways to make the a priori algorithm more efficient, okay? Because a priori algorithm need to scan the database, generate the candidate, check whether the candidates are indeed frequent or not, remove the ones that are not frequent, and then go to the next round, right? So what we want to say is that, yeah, multiple data scans are really costly, and if you have longer patterns, you basically need to go from 1 item sets, 2 item sets, 3 item sets, all the way right up, and you're generating a lot of candidates. You're doing a lot of calculations, counting the support values, okay? Really, the main thing is that you're generating a lot of candidates, and turns out that many of them are not frequent. So in a way, you're wasting your effort, okay? So then one was asking a question, right? Can we just don't generate a candidate at all? We only find the patterns, knowing that they will be frequent, okay? That sounds like a magic, right? Turns out there is a way to do it, okay? So this is called FP growth, okay? So the high-level idea is that, okay, we don't want to be generating candidates and removing, counting support and removing many of them, okay? We want to have a guaranteed way to generate patterns that we know will be frequent, okay? So the high-level idea is this, okay? Let's look at this example. If I know ABC is a frequent item set, okay, and I then generate this data set, a subset, right? So DB is my full data set with everything, okay? Now I only select, right, the ones that contain ABC. Okay? And within this subset, right, now I found somehow D is a local frequent item. Okay, this set is much smaller, so finding this frequent item D is fairly efficient, okay? So once I know that D is frequent within this subset, ABCD is not guaranteed to be frequent. Why? Because we already know ABC is frequent, and then within that subset, D is frequent. So ABC has already occurred, right? And now when I count D, within that subset, D is frequent. So I'm guaranteed, right? ABCD will be a frequent pattern, okay? So this is a simple example, but this really shows us, right? We're not generating candidates. We just want to find those subsets, and within the subset, if they're frequent, then the combination would be frequent. Now let's look at how we do it, okay, for the overall process. Still starting with our transaction table, okay, make it simple, 5 transactions. And then this is the items actually is bought in the individual transactions. First round, that's the same as a priori algorithm. You need to at least 1 scan, right? You need to check what is in your data set, okay? Make 1 scan, identify those unique items, count their support values, so you can find the frequent 1 item sets, right? This is the same, okay? So once you have done, oh, by the way, yeah, our minimal support is 0.6, so that means out of the 5 transactions, I need how many occurrences? 0.6 out of 5. Come on. How many occurrences do I need for an item set to be considered frequent? 3, right? So we're counting 3 occurrences, okay? So now with that, okay, I can already, this is actually, so with this, you can do the calculations, but we will actually then be able to remove the 1 item sets that are not frequent, right? Again, using the a priori pooling approach, if the single items are not frequent, I can ignore them already, right? They're not going to be frequent anyway, okay? So this is my next step, okay? So I sort, okay, 1, already removed the infrequent ones. Then I sort the frequent items in descending frequency, okay? This is what I do. So I take my transactions, for example, like this is the first one, okay? I need to sort it. So actually, I should show the next slide. So to make it a little bit easier, because this is the frequency count, okay? So if I count those transactions, I know F is frequent, has occurred 4 times. C is frequent, occurred 4 times. I have A, B, and P, each occurring 3 times, so these are all frequent. And then I think the P is frequent, O is not, and then L is not frequent, J is not. Those are the ones I'll just remove, okay? So I take each transaction. So the first one, remove the infrequent ones and sort it based on this table, okay? So by frequency, but also like alphabetical. So it's like FC, they're the same. Well, actually, why is it FC? But anyway, so yeah, this is the order I'm using, okay? So now I have FC, A, and P. Is this clear? Do you know how we get from this one to this one? Yes? Okay, so I take each transaction, right, remove the infrequent items, sort it, okay, based on the frequency. Okay, so now first one is easy, right? F, C, A, and P, so I will just build this tree. We'll gradually build this up, okay? So we're using a header table. So header table is basically a list, okay, or table of lists, okay? So each one, right, so F, that's basically the list of everything of F occurring in my tree. C is also pointing to the list of things that are like all the C's occurring in the tree. At this point, it's just 1, right? So if you build the first one, we're basically saying that, okay, I have F occurring once, C occurring once, A occurring once, M occurring once, P occurring once. Simple. Okay? This is after 1 transaction. I build 1 tree, okay? Or the very beginning of the tree. What happens if I add the next one? Second transaction, okay? So after reordering, removing infrequent ones, I have F, C, A, B, M. Okay, so now we need to add this in, right? So if I come in from the root node, F, okay, I have another F, so F now becomes 2. right? I have 2F now, okay? Next one, I have C. Great, it still is C, okay? So now I have seen 2 of C. Similarly, A, okay? So F, C, A all the way down, these are all good, okay? They're the same, so I just add a number, right? Count this up, so it's all 2 now. Next one is B. So B, I don't have it, so I need a branch this way. So B is occurring once here, and then next one is M, okay? So M is occurring, so let me actually bring up the next one, okay? So once I add it, like here is all the same, but adding just a count plus 1. Here I have B going to another branch. M is also separate, knowing that I'm not combining M with this M here because it has to follow B, so it's the other branch, okay? But I'm using my linked list, so here, right? So that's how I'm pointing from here, this M, to this node containing M, and then this node. So I can traverse, right, all the nodes in the tree that are containing the same item. It is clear so far? Following me? Okay, so we're basically constructing this tree, right, using this order, okay? This order is important, okay? But you basically just following this order, like adding those transactions in, and you're counting them, adding branches as needed, okay? When I'm done, okay, with our simple example here, this is the final tree, okay? So I have seen, let's say here, F occurred 4 times, which is true, right? You have F, 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 F. So 4 of those transactions started with F. 1 of them started with C, and that's this one, okay? So you will see that a CBP is this branch, okay? And then I have the other, for example, FB, so you don't have F here, there's another B node here just by itself, okay? And I have all the, like the header table, right? I need to maintain the list. So each of those link the particular items they have, okay? This is my tree, okay? So you can play with this, like if you want to add, like going from the previous one, we have shown first transactions, second transaction, you can actually also do the third, fourth, and fifth so that you would arrive at this tree, okay? So after I'm done, this is my tree. But then with this, how do I generate my frequent patterns, okay? So the tree so far, you can see is a basically kind of what we call a prefix tree, okay? What means that is that once you get to this point, this is like our subset, right? With underneath this branch, it's everything that has started with F. Make sense? Right? And then underneath, for example, this branch, so that means everything that would have F and a C. Clear? So that is the subset I'm trying to come up with, okay? Now with that, we're trying to bring out what we call conditional pattern base, okay? What we're basically doing is that kind of going upwards, right? So because this is a prefix, right? So with this, let me look at this particular example, right? Now you can try to traverse upwards, okay? Meaning that find your parent and find your like grandparent, okay? So if I use a C, okay, C here, I know like for basically what I do is that, okay, F is 4 times by itself. F is a frequent item, right? That I already know. But now let's look at the C, okay? C, using this link, right? I can see C occurred here 3 times and then once here, okay? So if you see this one, if you take this one, it's not frequent yet. Remember, we need 3 occurrences, right? So C here is not frequent, okay? So I'll just, like if I traverse all the way here, it's not frequent. I don't have anything. But if I go up this branch, okay? So C, which has 3 occurrences here, I go up, I know there's F, right? So it's within this subset that has F, okay? So that means if I go upwards, C is frequent, F is also frequent, and here F is only 3. Why? I had F occurring 4 times here, but I only have C occurring 3 times. So for the conditional pattern base for C, F only had 3. Is that clear? Right? Because you think about it, right? If you go from the top, say F has 4 occurrences, right? But then C occurred 3 times. So it means that there's another branch that had F and something else, but not C. Okay? So I'm going backwards. I know that C has occurred 3 times, and F is above it. So that means it must have, like every time I have C, I would have F anyway, right? And that is F3, okay? Is this clear? So you're basically traversing up because you're within that subset, knowing that F has already occurred. Okay? So pick another one. Let me see. Let's look at M, okay? M is here, right? I have 2 cases. One is M2, this is M1. So at this point, none of them is frequent. They don't have my frequency, like number yet, right? So I keep going upwards. When they merge or they meet together at A3, that is when I have seen 3 of M. Make sense? Right? Twice on this branch, once on this branch. When they get to the middle point, when they meet, right? This is when I have 3M, okay? So this is when I have M. By now, I have FCA, right, M. This is one branch coming up here, okay? So FCA and then M, that has occurred 2 times. FCAB, that is time when I know B, right? So this is one occurrence here, okay? But as we build this up, why is this useful, right? Now we're ready to generate a pattern, okay? So still using M as our example, right? As we said, for M, we have FCA occurring twice, FCAB occurring once, okay? So individually, they're not frequent yet, but we can combine them. Remember, we need to get to 3, right, the threshold, okay? So now, naturally, you can already see that, like, F has occurred 3 times when you combine them all together, right? So this is for the M. So M's conditional FP tree would have the sub-branch going up like this, right? So A occurring 3 times, C occurring 3 times, F occurring 3 times. Okay, so great. Now I know M is frequent as an individual item, okay? And if you want to generate 2 item sets, frequent 2 item sets containing M, that basically means I'll take each of those and combine with M. That's my 2 item sets. So I have FM, CM, AM. Clear? Okay. Same thing, if I want to do the 3 item sets, I need 2 items from in my conditional FP tree. So I need 2 of them. I'll have FC, FA, and CA. So that's my combination. For the 4 item sets, same thing, all 3 of them combining M. So in this case, right, using the M's conditional FP tree, I would generate all those patterns, and they're guaranteed to be frequent. Okay, this takes a little bit of time to process, okay? Let's pick another one, just to make sure you understand the process, okay? Let's see, let's do, I don't have a good way to do the other one. P, okay? So P has occurred 3 times. So I know P is a frequent item, right? And now if I use the list, I know there's like 2 occurrences of P here, 1 occurrences of a P here, okay? So 2 and 1, individually they're not frequent yet. So I need to traverse back, right, backwards, until I get to a joint branch where it will get me to 3 or more, okay? When do I get that? So if I P all the way up, not yet. So when does this node and this node, their branch will converge? Where? On the top, right? So the root. So that means any of those nodes, if I take them, they don't have enough of P yet, okay? So it's only when P2 and P1 merge all the way here, that's when I get a 3, okay? So now if you look at the frequent item sets containing P, besides P itself, do you have any other patterns that can contain P and is frequent? No, because you don't have, as I said, like you only get to 3 when you get here, and now you don't have any other items to combine with P. Clear? Okay, so again, this is a way that you traverse back until you meet the threshold, And from there up, these are all the things that you could combine, okay? But if you're already at the top, you don't have anything that you can combine, okay? So in M's case, right, I have 3 here. So A, C, F would all be frequent. They can all be combined with M, okay? But if I'm doing this with P, I don't have anything until I get here. So so P condition of P tree would be all the way to here. It's empty, right? So you don't have any other item to combine with P. Make sense? Generally? Okay. Let me check time. Okay, let me see. Let's try another one, B. Okay. B has occurred 3 times. Okay. So using my link here, so B occurred once here, another one here. So if I traverse back, where do I merge when I get to 3? So this one going up, up, up. Here is when I have a frequency of what? 2, right? Because I have 2 branches now, but not yet, right? So I still need to go one more step up to meet this branch. Again, I get to the root node. I don't have anything else to combine with me, okay? So as you can see, right, this is actually how you can do significant reduction of those patterns that you need to consider, right? Because you only consider them when they're frequent enough, okay? So like your tree maintains all the information, but because it's ordered, it's a prefix tree, right? And only maintaining the frequent occurrences within the sub-branches. So all you need to do, right, to find those frequent patterns is to traverse back, keep on going until you are frequent enough, and then you just take all the top ones to generate your patterns, okay? So that process is much more efficient. This tree is also much smaller compared to the whole list of your candidates or your transactions. Okay, so if you're interested, you can go to the paper and actually get more details. But at a high level, right? So the frequent pattern or FP tree or FP growth is the frequent pattern growth. So what we're doing is that instead of generating candidates and then check the support, then remove the infrequent ones, we use this prefix tree to guarantee the patterns we generate would be frequent. Okay, so the high-level thing, right? So the process, what we did, right? So we have the example in the slides. So if you want to review it, you can just take the whole process. First one is simple, right? Same thing. Go through your database once, find the frequent items, 1 item set, right? Remove the infrequent ones because they will not be relevant anymore, right? Okay, and then you construct this conditional pattern base, okay? So what you're basically doing is that you're putting, right, as you add each transactions, right, now the transactions are ordered and no longer contain the infrequent items, okay? So it's ordered frequent items, and now you build your tree by adding the transactions one after another, okay? So you just need that order to figure out where you add this particular node, right? Or you're just adding the count, okay? But you need that header table. Remember, the header table is for each item, so I can traverse the tree in the horizontal way, okay? Once you have that, right, for every item, you find this conditional FP tree. So basically, let's say you find all the nodes of this item in the tree. Now go backwards, right? You traverse upward until you have sufficient frequency. And then anything above that would be the combinations you would consider to generate your frequent patterns. Okay? So all you need to do is just once you have the whole tree, right, you go through your items, individual frequent items, generate the condition FP tree, create the corresponding patterns, and then you're done. Okay. You don't need to worry about the implementation, but I want you to understand the process, okay? And for our next assignment, this is a required component for graduate section, okay? So it's a required technique. So make sure you understand how this example works, all right? Okay. So a quick note. So if you look at the original paper, they actually include some comparison, right? This actually is related to the evaluation, right? Because here, well, let's say you want to show your new method, right, is more efficient compared to the a priori algorithm, okay? So in this particular case, it's about efficiency, okay? So on my y-axis, right, it's a running time. How long does it take for me to find those frequent items, frequent item sets, okay? But your x-axis, that is you're controlling, right? Because with the frequent pattern mining, this is support, right? Remember the minimal support, right? That is what we're doing, okay? So one quick question. So if I increase my support threshold, do I get a more frequent patterns or fewer frequent patterns? If I increase the threshold, more or fewer? Less, right? Because higher threshold means that you need to be more frequent to be considered a frequent pattern, right? So that's why if you look at it like towards this end, they're similar. Like the two methods have similar running time. Why? Because your higher threshold means that you don't have that many patterns or candidates to consider, right? So the benefit of like FP growth is not that clear. But this is when these two methods vary significantly. So we have lower threshold, right? But this is still like actually very important, like for real world, right? For example, like 1% is already very significant pattern, okay? And in this case, you have many potential patterns that are frequent, okay? So if you're using the a priori algorithm, this is what they have, right? No. This is this one is the priori and this one is the FP growth. So you will see that like the priori algorithm, as you reduce the threshold, like meaning that you have more and more patterns to consider, the running time, right, grows up very quickly. This is almost exponential because when you have more patterns, like every time you add another like K is bigger, right, it's exponential growth in terms of your potential candidates. Okay, so this one quickly becomes too big, right? Takes too long to run. Okay, while with FP growth, you can see that, right? It's the time still pretty manageable as you reduce this, and later on, yeah, it gets bigger, but that's only because things are you consider probably too low a threshold. They're just too many. So in this case, you're not doing enough filtering anyway, because you're generating your patterns, which is almost the same as your candidates. Okay, make sense? So this is the kind of thing, like you don't need to like get all the technical detail, but I want you, in this case, I want you to understand how you say do a comparison and how you interpret. If I'm showing you this like figure, you have a way of interpreting what you are seeing from this figure. Make sense? Because we're comparing running time of two different methods and the different support thresholds. Okay? So same thing, right, for your project, right, especially later on towards the later part of the project, you will have results, right? So just make sure you find the best way to show your result, but make sure you have some explanation or interpretation of the result, okay? So like sometimes we all have the tendencies, okay, I run the results, I put it up, right? So here's a table, here's a figure, here you go. But what do you mean, right? What do you mean in this table, in this figure? What we're looking at, right? What do you learn from this table? Okay, so make sure you add some content, right? It's the interpretation of your results. Okay, all right. Continuing. Okay, so we talk about the basic concepts of frequent patterns, right? We then talk about a few different approaches, right? A priori algorithm, how we can make it more efficient, and a totally different one that's still for finding frequent patterns. Okay, now let's talk a little more in terms of the interestedness, right? So we said, okay, whatever frequent pattern you found, right? You ultimately want to say, okay, whether this pattern is interesting, okay? So in this particular case, excuse me, right? We say that, okay, you can generate a lot of patterns, right? Even for item sets, if you just do the combinations, it's huge, right? You can generate many, many of them. Okay, but in many real world settings, right? Not all the patterns are interesting, okay? So we will talk about our objective measures, right? You can compute support confidence values that would allow us to say whether this is interesting or not. You can use this as a threshold, right, for your method, like mining only the patterns that are above certain threshold. And then you can also compare patterns, right, based on those values, okay? So you can see this one is more significant. The other one is important, okay? So those are good. Those are objective measures. Great. Okay. But in the real world, there are actually a lot of subjective measures. Okay. Meaning that for your particular problem, right? When different people are looking at this, they may think differently in terms of whether this is interesting or not. Okay. Some examples. First one. Okay. Query based. That means you may be finding some patterns, right? That's like say has high support, high confidence. But that's not what I'm concerned about, right? So I say, oh, yeah, we're doing fine in terms of like the sales in, say, the North America. We're good. So that is more about, okay, I'm more interested in, say, maybe consumer electronics or another category of items that have either higher or lower sales or they're being like sold together, right? So the user may have some specification about what types of information. Even though they cannot spell it out completely, they may say, okay, I'm more interested in those kind of patterns. Okay, sorry, that you don't really know upfront, but it's about whether it's relevant for that particular problem and particular user. Another one, this like really connects to whether this is new, right? Because if it's something that you kind of already know, okay, and then you're just like validating, yeah, that's useful, but probably it's more interesting you find something new and it's still significant. Right? So this is related to like knowledge base, right? Meaning that what's already known, and now you have found something that's unexpected, counterintuitive, but it's true, right? Or you have some kind of like freshness, timeless. That means like you have actually adding some new knowledge. Okay? So a lot of the times, like as you're kind of defining your project, defining your questions, right? That's why it's important. You want to situate your analysis. Okay, in the problem and knowing the application scenario so that you can ask the right question, put your effort in the right direction, and have a way of interpreting the results, right, to make it more relevant or significant, right, for your potential customers. Okay? Now, so we talk about association rule, right, support and confidence. So by now, hopefully you all know, right, what is support, what is confidence. Suppose you have this rule. Say through my data set, right? I have, say, a population. I'm checking like whether they play basketball, whether they eat cereal. So now I found a particular rule says that if somebody, okay, plays basketball, okay, then there's a high chance, right? This is my confidence, right? 66.7% that this person also eats cereal, okay? So you can see, right? This you can see like 40% is pretty high, right? It's very high support, and 66.7 is pretty high confidence, okay? She may say, okay, this is a rule that's interesting. Turns out we're actually missing something, okay? So in this particular case, right, if you look at your population, right, 75% of your student population actually eat cereal. What does it mean? So if you look at the whole set of like whole population of students, 3/4 of them eat cereal. But now if you look at the students who play basketball, and then within that subset, there's a lower percentage of those students eating cereal. Okay, so how do we interpret that? So people who play basketball are less likely to eat cereal. Okay? So now we're actually having, so instead of just say using the confidence, meaning that this is just a conditional probability, right? But now we're actually saying that, okay, we will actually say whether it's more likely or less likely. Make sense? Okay, and that is what we're trying to capture, right? We have been mentioning this, correlation, okay? So we have been using correlation for a little bit. That means like things are occurring, right, in the correlated way, okay? But the correlation can be positive or negative, or no correlation, okay? So if it's a no correlate, that means like they're independent, right? Doesn't matter. If something has occurred, the other thing occur with the same probability. But sometimes if they're correlated, then you are seeing some impact of changes of the probability of occurring. Okay, so now we're adding in another term, right? That's a correlation. There are a few different ways to measure correlation, okay? So one is called the lift, okay? So the idea of a lift is simple, okay? So if you look at this, right? So my denominator is the individual probability of A and B occurring, okay? And then I look at the probability of A and B occurring together. Remember, A and B, those are item sets. That's why I'm using union, Okay, so it's A union B, right? So it's basically saying those items occurring together. Okay, so if they are independent, the probability of them occurring together would be same as the independent occurrence, right? Then you would have a value of what? If it's independent, 1, right? So if the value would be 1, that is when it's independent. Okay? If the lift value is above 1, what does it mean? The combined probability is bigger than the individual probability. That means they're more likely. They increase the probability of something happening. Okay, think about it. Yeah, if you're going to a party, if your friends are going, you're probably more likely to go there, right? So that's the idea, right? If there's a positive correlation, okay? So individually, if you just choose it individually, right, just say, okay, yeah, I may go if I have time, or like, oh, I'm too busy, I may not be able to go. But if you see who's going, okay, if many of your friends are going, you're more likely to go. And if there are people you don't like, already signed up, they say they're going. So you may actually say, oh, no, I was thinking about it. If they're going, I'm not going. Okay, that's actually what we're trying to capture, right? So basically, right, negative, like negative dependent or positive dependence, right? So those are the 3 scenarios, right? Either doesn't matter, okay, or positive. So it's like something occurring actually increase the chance of me like occurring or going, or something occurring is a decrease in the chance of the other thing occurring, okay? All right, so let's look at example. So this is my play basketball eating cereal, right? So earlier I say if you just do the like association rule, okay, you can calculate that. Like there's a reasonable strong rule, but we say, okay, let's look at the correlation. Okay, so if you take this table, okay, hopefully by now you know how to read the table, okay? So we have 2 variables or 2 items, items. Either like say basketball, like whether you have this person has the attribute of playing basketball or not, or eating cereal or not, right? So 2,000 means that out of my 5,000 students, 2,000 of them play basketball, eat cereal, okay? So if you take all this together, now you can calculate, right, the lift value. Okay, so this one is lift of a BC. So that means that B is playing basketball, C is eating cereal, and I have a value of 0.89. So it's less than 1, meaning negative correlation, right? It's reducing the chance. So meaning that these 2 are negative correlated. So playing basketball actually reduces the chance of eating cereal. Okay? Now if I do a different calculation, right? So I look at playing basketball, not eating cereal. Okay? Now I have a value that is above 1. So that means positive correlation, right? So that means playing basketball is positive correlated with not eating cereal. Make sense? All right, okay, so that is just one way, right, for you to calculate it. And the next one, hopefully this is a familiar one. This is the chi-square analysis, right, which we have been talking about. You can use that to calculate the correlations, okay? So same table, okay? The process we're basically doing is that we calculate the expected value for each of those combinations, and then we're looking at the difference, right? The squared sum of the differences for each of those cases, okay? And then we get a value, okay? We mentioned that if you're talking about 2 binary variables, if you get a significance value, a chi-square value that's more than 10, it's considered correlated, okay? So in this case, I have 200 something, so we know it's correlated. But with this value, can I say it's a positive or negative correlation? I know it's correlated, but I don't know which direction it is, right? Because it's the square value and sum of a square value. So with that, now you need to do a little bit further investigation. So you basically compare your actual occurrence and the expected occurrence, right? So in this case, this is eating cereal and playing basketball, right? So my observed instance is 2,000. My expected value will be 2250. So that means it's below the expected value, okay? So expected value is assuming independence, okay? So now if it's below my threshold, that means it's negatively correlated. Make sense? So I need 2 steps, right? So I have the first step, doing the chi-square calculation. When I know it's above 10, I know this one is correlated, okay? But then when I look at the individual scenarios, comparing the observed value and the expected values, right? If it's below the expected value, it's negative. Otherwise, it's positive. Okay. Okay, so we'll probably skip some of the discussions, but there are a lot more measures, okay, for correlations, okay? So in the actual setting, right, you will actually be looking at a few different things, okay? One key cell call out is about this null transactions. Remember, we were talking about when neither happens, right? So in this case, right, so for example, this is a mu kind of theory, I think, right? If the null transaction is a big number or much bigger number dominating the other ones, then you want to choose a measure that ignores that, okay? So let me quickly jump to the reminder, as I said, right? These are the things, okay? Make sure, please finish the survey by today. Tomorrow we're going to post the meeting schedule, okay? And then next week we'll be meeting with each groups to discuss your projects, and then make sure you submit those. Oops. Why is that? Okay, so make sure you submit those items by next Friday. Okay, that's all for today. Thank you.